So we looked at binary compounds, which have 2 elements. Now we're going to look at ternary, which have 3 elements in the compound. When we do ternary compounds, a lot of this goes back to the most common forms. These are the 6 most common forms which I require you to know. You need to know these 6 most common forms, and these all end in ic. The number of hydrogen and the number of oxygen is important. So H2SO4 is sulfuric, H3PO4 is phosphoric, HNO3 is nitric, and so forth. Everything kind of stems off these 6 most common forms. The first type of ternary compound is a ternary acid, which has hydrogen, a nonmetal, and oxygen. We're going to go back to those most common forms and use the following suffixes and prefixes. So with acids, I can take the most common form and add an oxygen. I would use the prefix per, then the nonmetal stem, and then ic acid would follow. If it's the most common form, I'm just going to name as indicated. I can subtract an oxygen from the most common form, and the suffix, instead of being ic, would change to us. And then finally, I can take the most common form and subtract 2 oxygen. I would use the prefix hypo, and then OUS acid. So let me go through some examples. And I will use sulfuric acid as my base. So sulfuric acid is H2SO4. That's the most common form. What I can do is I can add oxygen. So I can have a compound as H2SO5. If I add an oxygen, I add a prefix per. So H2SO5 would just be per sulfuric acid. I can take the most common form and subtract oxygen. I could have H2SO3. Instead of ic, it would be us. So H2SO3 would be sulfurous acid. And then finally, I can subtract 2 oxygen from the most common form. H2SO2, my prefix hypo, and then sulfurous. So essentially, from every one of those most common forms, I can get 4 possible compounds. Notice the number of hydrogen did not change throughout, just the number of oxygen changed. And that's going to tell me what prefix and what suffix to use. So let's say you have a compound, hypocarbonous acid. And I ask you, what's the formula for hypocarbonous acid? Well, hypo means you lose 2 from the most common form. So go back to that list of the most common, and if I lose 2 oxygen, it was H2CO3, now it's going to be H2CO1. That would be hypocarbonous acid. Or if I ask you, what is pernitric acid? Pernitric acid. Per means you add 1 oxygen, so instead of HNO3, pernitric is HNO4. So with the acids, it all stems from those most common forms. Second type of ternary compounds are bases. Bases are pretty straightforward. They have a metal plus the hydroxide group. NaOH is a base. And the way we're going to name these, we're going to name the metal first, and then just hydroxide, and that takes care of the OH portion. So NaOH is sodium hydroxide. If I give you the name, I say calcium hydroxide, and you're asked to give me the formula. Calcium Ca, hydroxide, OH, but we do have to balance charges like we do in most compounds. Calcium is in group 2, and OH is always in -1. So we do have to cross charges with the bases. But bases always have the hydroxide group plus a metal. Third type of ternary compounds are ternary salts, and these are probably the most difficult to name. These have a metal, nonmetal, and oxygen. They're named from the acid from which they are produced. Basically, we're taking the acid and we're replacing hydrogen with a metal. We're going to name the metal first, but then we're going to change the suffix of the acid. Ic becomes ate, and us becomes ite. So let me go through some examples of these ternary salts. And like I said, these are probably the most difficult to name. NaNO3 is a ternary salt, metal first. I'm going to go back to the acid. NO3 comes from this acid, HNO3. I'm going to name that acid. HNO3 is nitric. That's the most common form. Essentially what I'm doing, though, I'm replacing hydrogen with a metal, and that makes it a salt. But I would not say sodium nitric. The ick becomes 8. So when it's with a metal, the name of this compound is sodium nitrate. Sodium nitrate. The ick becomes 8 because it's with a metal. Okay, here's another ternary salt. Got a metal, potassium. I'm going to go back to the acid. ClO4 comes from, go back to your most common forms, comes from HClO4. I'm going to name this acid. HClO4 is, I'm adding an oxygen, so it's not chloric, it's perchloric. But when you put it with a metal, when you replace that hydrogen, it's not perchloric, it's perchlorate. So KClO4, that's the salt, is potassium perchlorate. Okay, let's work the other way. Let's say I have the name lithium. Let's do phosphite. Okay, lithium, that's easy. Li, it's got a +1 charge. Phosphite comes from phosphorus acid. So I need to go back to my acids. Phosphorus, I'm going to go ahead and write that acid down. H3PO, phosphorus means I've lost 1, so PO3. When I put this phosphorus with a metal, I get rid of the hydrogen. You always get rid of the hydrogen. So phosphite is just this PO3 portion. How do I get the charge on PO3? I look at the number of hydrogen. In this case, there were 3 hydrogen that I'm getting rid of. So PO3 has a charge of -3. So how do I get the charge on the PO3? Look at the number of hydrogen, -3 charge. So lithium with PO3, and that's a -3 charge. Cross charges and you get Li3PO3. That is lithium phosphite. And like I said, these just take lots of practice, and they are the most difficult to name, these ternary salts. Let's do one more. Calcium hyposulfite. Okay, calcium's easy. It's got a +2 charge. It's in group 2. Hyposulfite comes from hypo sulfurous. I'm going to go ahead and write that acid down. Hypo means I've lost 2 oxygen. So hyposulfurous, instead of H2SO4, I've lost 2, so it's going to be H2SO2. I want hyposulfite, so I'm getting rid of the hydrogen. Once I get rid of those 2 hydrogen, that means the charge on SO2 is -2 because I've lost 2 hydrogen. So hyposulfite is SO2, -2 charge. Those essentially cancel out. So calcium hyposulfite is CaSO2.